Hey friends, we're back. We're going to look at our second day of doing 9.2 practice, which is the area between. So sometimes that's between two curves, sometimes it's between a left and a right, sometimes it's a top and a bottom, so we have to make sure we understand the difference. When we look here at number 1, we're actually going to be looking at one of the more harder problems, kind of like the very last one that we did at the end of the notes on block day. So number 1 says, let R be the region in the first quadrant bounded by the x-axis, the graph of x equals y squared plus 2, and the line x equals 4. Which of the following integrals gives the area of R? So the first thing you need to make sure that you notice on a problem like this is the way that these two functions given are written. Notice they're not given as y equals, they are given as x equals. This means when you are doing your problem, your integral, your values here, your a and your b, or the other time we called it a c and a d, these are actually going to be y values because your functions are going to be in terms of y. Okay, and that means this needs to be the right function minus the left function. Okay, so please remember that that is the part that is different about a problem like this. So the first thing that we want to do is we want to be able to get a picture of this. So we need to write this so it's in terms of y. So that means let's move this 2 to the other side with the x. So I'll do that over here. So y squared equals x minus 2. Then square root both sides. Remember, when we take a square root, we really get plus or minus, but because this is going to be in the first quadrant, I'm only concerned with the positive. So this is just going to be the square root of x minus 2. Okay, to make it easier on yourself, just punch that into the table on your calculator. You're going to get a graph that looks like this. Okay, and what we're concerned about is that equation, which is right there, and the line x equals 4. So remember, this is going to be a vertical line. X equals 4 goes through every x value that's 4, so that is this vertical line. So this is x equals 4. So it also said bounded by the x-axis, so that's this piece. So we're looking at the area of this section here. Okay, so remember I said because this function was in terms of y, that means we're doing a right function minus a left function. So my right function here is this x equals 4. My left function here is actually this function. So this one's going to be our left function. This one's going to be our right function. Okay. Then the only other difference we said was these two limits need to be in terms of y. So that means I need to know what's the smallest y value we have here. Well, the smallest y value we have here is 0. And the biggest y value we have here is whatever the y value is here. So the easiest way to do is look on the calculator where my x value is 4, and we find out that our y value here is actually 1.4142. Okay. Obviously, if you're looking at our answer choices, none of those are a 1.412, but if you use your calculator, you only have the choice of a square root of 2 over a 4, and the square root of 2 is actually that decimal. So we know this is not one of our answers. Okay. So then we just need to make sure that our equation is written in terms of our right function first, which we said it was this, and then we're going to subtract out our left function, which was this, and that all needs to be taken with respect to y because the functions are in terms of y. Okay, so this first one is actually going to be a. Okay, the next one actually had a little typo in it. There needs to be a square right here, so if you will, go ahead and put a square on that. Circle number 2, circle number 3. These are ones I'm going to have you go back and do on your own and check. Okay, you can actually skip number 4 and number 5 if you want to do them. They're pretty similar to number 2 and 3. Okay, I do want to look down here at number 6. Number 6 is just setting up the right equation, it says air is being pumped into a spherical balloon at a rate of r of t equals t plus cosine t plus 1, and that's cubic centimeters per minute. But there's a small hole in the balloon, and at the same time air is leaking out. So as air is being pumped in, air is leaking out at the rate of L of t equals 0.25 inverse tangent of t, the cubic centimeters per minute. Which of the following is true for 0 to 10 minutes? So minutes from 0 to 10. Well, so first off, we know it can't be this one because I don't have my 0 and 10 in there. This is just only plugging in a 0 into those functions. That's not what we need. So if we're trying to find which is true, well, we know our integral is going to go from 0 to 10, and we know that r of t is going to be our bigger function. It's going to be on top because as the balloon gets bigger, that function is getting larger. Okay? And then our L of t is definitely the smaller function because it's getting smaller and smaller every time. So we know that this is our top function and this is our bottom function. Okay, so this one says that that is representing the volume of the balloon after the first 10 minutes. Okay, this one has that same function, except it has the 1/10 in the front. The 1/10, if you'll remember, that was helping us find an average. So this says represents the increase in the volume each minute during the first 10 minutes. And then the last one says this represents the increase in volume during the first 10 minutes. So it's all in the wording on this one. You need to make sure that you know that what we're finding is our volume during those first 10 minutes. So that's going to give us our volume for those first 10 minutes during them. Not what's after, not what's happening, what they have after the fact. Not the increase in the volume each minute, because that's going to tell you each individual. This is going to tell you the whole thing. So this one should be C. Okay? All right, so let's look on to the back side or the next side of this paper. Okay, so we're on the next page, looking here at number 7. Number 7 and number 8, I'm giving you some functions, and it says that we're finding to sketch the region and then find the area that's bounded by those regions, or the area of the region. So we're looking at where they intersect. Alright, so you'll see I've already got my x and y axes on both of these, so if you need to pause it and copy those down, go ahead. Okay, when we put these functions into our calculator, we're going to get where they graph, so that's all I would do is put this into y1 in your calculator and we're going to graph it. Okay, when we graph this function, it is a cubic function. It goes through, sorry, that the 1 should be here. These should be 2's. Okay, it's going to go through here at 0, 1, and then it has a point up here at 2, 1. I guess for sake of keeping it scaled, let's call the 1 here, just to keep it a little more scaled for you. And then also here. So it's going to look something like this type of function, where we've got a cubic going on. Okay, then this one, x minus 1, this is just a nice linear function, but it's being shifted down here by 1, so this one is actually going to be a nice straight line. Very hard graph to see because what we're looking at is this space in between here and this space here. So we've got two pieces here that we're looking at. Sorry, I keep turning my paper. Okay, so we actually need to calculate two different functions. So what I would do is let's call this y1 because that's where we put it in our calculator. Let's call this y2. So on just this first piece, this piece right here, so if I'm only looking at this part of the function, okay, my lower limit is 0, my upper limit is 1, and the top function is my cubic function, and the bottom function is the linear function. So when we write out that integral, it's going to look like this. From 0 to 1, then my top function was the x minus 1 cubed minus the bottom function, which was the x minus 1, okay, with respect to x. And then we're going to have to add the other piece in. So the other piece in is this part of the graph, okay, because it's going to intersect again right there. It's going to go from the lower limit of 1 to the upper limit of 2. Okay, so my lower limit is 1 and my upper limit is 2. This time on this, the top function is the linear and the bottom function is the cubic. So that means this one is going to have the x minus 1 first minus x minus 1 cubed with respect to x. Okay, you can punch this one into your calculator, you can punch this one in and then add them together. You actually could punch it all in at one time. If you still have this function in y1 and this function in y2, you can do that thing that I showed you last time where you use the y-vars and just put a y1 here and a y2 here. On this one, it's going to be a y2 minus the y1. And we are going to get that this one is actually 0.25, this one is actually 0.25, so we're going to get 0.5 as the area. Okay. This other one over here, we've got our two functions. Okay, let's just call this one our y1. This one can be our y2. We've got a quadratic function, which is actually going to be here at negative 1, 0, 1, 1, or sorry, 0, 1, then 1, 4, and 2, 9. Okay, and then mirror those, you're going to get here and here. So this is the quadratic function that we're looking at. And then we have a linear function that we're looking at, which is going to go through the y-intercept of 5. So 1, 2, 3, 4, 5. It's going to rise 2, run 1. So rise 2, run 1. Rise 2, run 1. 2, 1, 1. And down here. Okay, so I'm just going to sketch that. Alright, hopefully we all can see, sorry, didn't go through that very well. This is the area that we need to find, the shaded area. So our functions are in terms of x, that means our integral should be our x value. So my lowest x value that we have is going to be this x value, which is a negative 2. My biggest x value is going to be this x value, which is a positive 2. Then we have to figure out our top function was the linear. So this was the top function. So 2x plus 5, or if you're doing your y's, that would be y2. And our bottom function was the quadratic, which was our first function. So x squared plus 2x plus 1. That's with respect to x. When we punch this into our calculator, it's going to give us 10.6 repeating, or 667. Or if you write it as a fraction, sometimes answers are in fraction form, 32/3. Alright, so I'm going to pause here on this video. I'm going to pick up on the next video and do the last 3, especially because number 11 is going to have a few more steps, and number 9 actually has 3 different parts to it. So see you in just a couple.